Hello scholars, welcome. Mr. Hinkle here, talking about the ocean, talking about the continents, talking about the interface, we call them coastlines, and specifically the shoreline, which is where the water is moving up and down between high tide and low tide, and the features that are associated with them. So let's get into it. We'll define zones of the seashore, talk about longshore drift, and then get into emergent and submergent coastlines, and the depositional and erosional features associated with each of them. So coastlines are dynamic, high-energy geologic environments. The product of erosion and deposition, they are not constant. They are ever-changing. They are where we go to enjoy our time on the beach. So let's learn about what we are enjoying, shall we? So we can break shorelines into zones. We've got offshore, nearshore, the surf zone, and the, offshore, nearshore, the surf zone, the foreshore, and the backshore. Now, different processes are happening in each of them, and we can think about the movement of sand through various zones. But what we really want to think about in terms of the movement of sand is going to be longshore drift and longshore currents. So the movement of sand, let's see, shorelines. Let me do this. Okay, so this is the US. Here's Canada. Here's the Pacific Ocean. There are currents in the ocean that are related to global convection cells and the Coriolis effect. And what this creates is subtropical gyres, which are in the northern hemisphere, clockwise rotating masses of water. Now, if we look at the west coast of the United States, the current is from north to south. So the directions of the longshore current are north to south. Wave refraction means that as these waves are traveling down, like this, they bend. So that no matter where you are on the coastline, the waves look like they're traveling at you. Now, what this does is it creates swash and backwash. The longshore current is smashing against, so it does come at an angle and then it moves straight down, near parallel. It's important to mention, near parallel. So the wave action brings sand onto the beach, and then gravity drags it straight down, and the net movement is in the direction of the longshore current. So two things happening here. We have longshore current, which is the direction the waves are moving, and then longshore drift, which is going to be the movement of sand down the beach. Now, this movement of sand, longshore drift and longshore current, leads to sediment transport, both deposition and erosion of that sand, which create shoreline features. You got it. Okay, two coastlines. They look very, very different here. On the top, we see an emergent coast. On the bottom, we see a submergent coast. And so you can think of it as the rocks are emerging out of the water in these emergent coasts, and then in submergent, the water is submerging all the features. And this gives us a host of two completely different types of features that are associated. Here we have common features on California's west coast. Here we have common features on the eastern seaboard of the United States. So let's get into each of these. The Bixby Bridge. This is a famous bridge. Big Sur, what do you see here? You see bedrock, big steep cliff. You see headland, 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 areas that are sticking out of into the ocean, showing, oh, you also see sand here, the net longshore current direction called longshore drift. So there's a lot of things that are happening here. But when you see this type of coastline, you know this is an emergent coast, which often has to do, let's go back a slide, with sea levels falling relative to land level. This can also mean active tectonics are lifting up the continental rock, so it can happen both ways. Now, these headlands are subject to erosion, and the headlands will erode, sea caves will form underneath in the bays. Those sea caves will erode more into sea arches. The sea arches will collapse, leaving sea stacks. And when the sand from the mainland connects out to a sea stack, we have what's called a tombolo. So again, features of emergent coastlines. I guess I could make a list. Nah, I've got it. I'm just going to keep going, keep talking. We got a few things to say here. Waves are powerful. They move sand around. In winter, the sand is drawn out into the offshore, and then in summer, the sand comes back to the near shore. And what we get are certain periods where the bedrock underneath the sand is exposed. And wave action actually cuts into that bedrock, forming a platform. And these are called wave-cut platforms, often with a notch at the base. And you can see wave-cut terraces that indicate sea level height at different points in Earth history. So I love it. I love geology and looking at different Earth surface features and being able to understand the processes that went into creating them. So again, emergent coastlines, because the coastline is emerging out of the sea. As opposed to this submergent coastline, this looks like a river valley, right? A dendritic river pattern where the main channel came like this with tributaries, smaller streams connecting to those tributaries. And that's what happened. That's how this landscape was carved, by river erosion. And then sea level rose relative to the land surface, submerging, flooding this river valley. And what is created in the process are barrier islands. So it might be hard to see, but here's a barrier island. Here's a barrier island. There are over 400 barrier islands on the east coast of the United States, because although any coastline, the length of any coastline, California has some emergent coasts, it has some submergent coasts. There's more submergent than emergent on the eastern seaboard, but any coastline can have either type. Here, here's the stat, 405 barrier islands, all of which are on the east coast in the Gulf of Mexico. So submerged coastlines will form sand that can extend out of a certain point. This is called a sand spit, a narrow landform, usually made of sand or gravel. Bays that form can have a sand spit. So this is a bay with a sand spit. If the sand spit were to come all the way across the way that it has here, that is called a bay mouth bar, a sand spit that forms across the length of the entire bay. Tidal flats, very flat areas where tides alternately flood and expose low, flat lying areas. Tidal currents create these asymmetrical ripple marks. This is Morro Bay. California again, so it's kind of what I was mentioning. California has both submergent and emergent coastlines. Morro Bay is cool. If you've never been, it's one of my favorite places in the world to adventure, to explore, to learn about the local geology. Highly recommend Morro Bay being on your list. The San Francisco Bay Estuary, submergent coast. Lagoons where spits, barrier islands, or other features partially cut off a body of water. The difference here is estuaries are vegetated, usually show a mixture of saline and fresh water that creates unique habitats of brackish water. Pretty cool. Okay. Special mentions for shorelines. So you got to watch out for these rip currents. Every single year, people die because they are caught in a rip current. And what happens is it's a unique suite of incoming water where there's a channel of water that will pull someone out into deep ocean water. What usually happens is the person gets scared and freaks out and tries to swim straight back in, but you can't overpower the rip current. If you are ever caught in a rip current, you swim sideways out of the rip current, and you might even be able to catch waves taking you back into shore. Number one thing to do, stay calm, make conscious decisions, and get out of the rip current as soon as possible. Next special shout out is underwater canyons. As we see here, the Monterey Canyon, bigger than the Grand Canyon. The Elkhorn Slough comes in, and then from there it carves a deep, deep underwater canyon into the landscape. These are awesome. They create turbidity currents, producing unique types of sedimentary rocks at their base on their submarine fans. All this existing underneath the water, and we had no idea. What the heck? Shorelines are where, coastlines in general, is where the ocean meets the land meets sea. But shorelines have specific types of features, and they're erosional, they're depositional, but we can lump them into submergent and emergent. Are the rocks coming up relative to the coastline, to the ocean level, sea level, or is the sea line coming up relative to the rocks, giving us different types of features? Spits, baymouth bars, estuaries, lagoons, tidal flats, and submergent. Emergent is going to have wave cut platforms, sea cliffs, bedrock, sea stacks, arches, and tombolos. So, shoreline features vary depending on tectonic setting and coastal processes. This has been our intro. This has been a look at shoreline features. Thank you so much. I'll see you again.